So the baseball is hit 3 feet above the ground at a velocity of 1,000 feet per second at an angle of 45 degrees with respect to the ground. Okay, the path of the baseball is given by this function where f of x is the height of the baseball and x is the distance from home plate. Okay, so here's what's going on here, and I have no idea what the scale is going to be. But here at 3 feet, the ball is released, it goes up, and it's going to come back down and hit the ground somewhere over here. So what is the maximum height of the ball? That means find the y coordinate of the vertex. Okay, so h is the x coordinate, negative b over 2a, which is negative 1 over 2 times negative 0.0032. So if I do that, I get this is 156.25. So now I have to find f of 156.25. So that's negative 0.0032 times 156.25 squared plus 156.25 plus 3. 156.25 squared plus 156.25 plus 3. And I get 81.125, and that's feet. Okay, so my vertex here is 156.25, 81.125. So 156 feet away from the plate, the maximum height is 81 feet. Okay, so how far is the ball when it hits the ground? That means find x when f of x is equal to 0. Okay, so I want to know when negative 0.0032 x to the second plus x plus 3 is equal to 0. Okay, straight to the quadratic formula. So A is negative 0.0032, B equals 1, C equals 3. Now, I hope I've got some room on the next page to do this. Oh, I do. I might be able to have enough room here. Okie dokie. So, x is equal to the opposite of b plus or minus the square root of b squared minus 4 times negative 0.0032 times c, all divided by 2 times negative 0.0032. Okay, so that's what we're doing. So let's just go ahead and split it up. Okay, so if I split it up into the plus and the minus, and I'm going to abbreviate here because I think you know what I'm doing here. All right, so for the plus, I'm taking negative 1 plus the square root of 1 squared minus 4 times negative 0.0032 times 3 divided by 2 times negative 0.0032, and I get negative 2.97. Okay, well, that's where if you extended this on, that is going to be that intersect there. So now I have to do this one. So negative 1, let me see. Let me just see if I can do it this way. And this one I get 315.47. So this is 315.47. So how far? So, and this is in feet. So that's the answer you want. That one doesn't work for us. Okie dokie. So let's go on now into 7.2, which is an introduction to polynomials. So we want to determine the end behavior of this. Now remember on the end behavior, here's where x goes to infinity. Here is where x goes to negative infinity. This is where f of x goes to infinity. And this is where f of x goes to negative infinity. So this is on your left and this is on your right. Okay. So let's see what's going on here. And then the table that I gave you in your notes about odd and even. All right, so determine the end behavior of each function. So the degree is 3, which is odd. The leading coefficient is negative 1, which is negative. So odd negative means on the left it goes up and on the right it goes down. Now in the appropriate notation, as x approaches negative infinity, f of x approaches infinity. On the right, as x approaches infinity, f of x approaches negative infinity. Okay, let's make sure it's in descending order. The degree is 5, which is odd. The coefficient or the leading coefficient is 1, which is positive. So that means my ends go like that. Now in the appropriate notation, as x approaches negative infinity, f of x approaches negative infinity. On the right, as x approaches infinity, f of x approaches infinity. Okay, so my degree is 4, which is even. Leading coefficient is 1, which is positive. That means on both ends it goes to infinity. So as x approaches negative infinity, f of x approaches infinity. As x approaches positive infinity, so does f of x. Okay. Here the degree is 4, which is even. The leading coefficient is negative 1, which is negative. So that means both ends go down. So as x approaches negative infinity, f of x approaches negative infinity. As x approaches infinity, so does f of x. I'm sorry, it also goes to negative infinity. Excuse me. Okay, so let's look at this. From the graph, we want to find the zeros and determine if their multiplicity is even or odd. Okay, remember odd, it crosses, even, it touches, or I call it bounce. Okay, so I've got a 0 and its multiplicity. So I have a 0 at -1. Since it crosses, it is odd. I'm sorry, odd multiplicity. Then I have a 0 at 0. It crosses, so it is also odd. And then I have a 0 at 2. Since it touches, or what I call bouncing, that means it must be even. Okay, so find the minimum possible degree. All right, well, there are a couple of things. The minimum possible degree deals with how many zeros you have and also how many turning points. So let's say the minimum possible degree, that would mean if it's an odd multiplicity, this would be 1, this would be 1, and this would be 2. That means there are 4 solutions. So the minimum possible degree is 4. Okay, determine whether the leading coefficient is positive or negative. Well, the degree is even. Both ends are going up to positive infinity, which means that the leading coefficient is positive. Okay, if the graph above is the graph of a function f of x, use the graph to solve the equation f of x equals 0. Okay, well, that just means find the solutions, find the x-intercepts. So the solutions are x equals -1, x equals 0, and x equals 2. And this one has a multiplicity of 2. Okay, same thing from this graph, and of course this goes on to negative infinity. Find the zeros and determine if their multiplicity is even or odd. All right, well, I have a 0 at -3. Since it bounces here, then the multiplicity is even. I have a 0 at -1. Since it crosses, it is odd. And I have a 0 at 1. It crosses, so it is odd. So the minimum possible degree, if this is even, then that would be a degree of 2. So the degree would be 2, 1, and 1. So the minimum possible degree is 4. The leading coefficient, both ends go down. So if I have both ends going down, that means it's even. And the leading coefficient is negative. Oh, and there's one more question on the graph. Use the graph to solve the equation x equals 0. Okay, well, it's just the where it crossed the axis. So x equals -3, x equals -1, and x equals 1. Okie dokie. Identify the zeros, their multiplicity, and whether the intercept is a touch point or a cross point. Okay, so I'm going to make a table for what my factor is, what the zero is, what the degree is, which tells me the multiplicity, and is it a touch or a cross. Okay, so if I have a factor of -2x, if I set that equal to 0, x equals 0. It has a degree of 1, which means the multiplicity is 1, which means it's a cross point. I have x plus 1 as a factor, which means I have a 0 of x equals -1. The degree is 3, which means the multiplicity is 3. That is odd, so it still crosses. Then I have x minus 3, which tells me that x is 3. The degree is 2, which means the multiplicity is 2, which means it is a touch point, or a bounce, as I call it. Okay, now I'm going to put a little less information on this because the degree and the multiplicity are the same thing. So if I ask for the multiplicity, you find that by finding the degree. All right, so the factor, the zero, the multiplicity, and the behavior. Okay, so I have 3x to the third. X is 0. The multiplicity is 3, so it is a cross point. I have a factor of x minus 7, so x is 7. The multiplicity is 5, which also means it's a cross point. And I have x plus 2, so the 0 is x equals -2. The multiplicity is 4, which means it's a touch point. Okay, sketch a graph of a polynomial with a positive leading coefficient and the following zeros. Okay, so I have 3 with a multiplicity of 2. So I'm going to start with the 0, the factor, and the multiplicity. So I have -3 with a multiplicity of 2. So the factor is x plus 3. I have a 0 of 0, which means the factor is just x. It has a multiplicity of 1. And 5, which means the factor is x minus 5 with a multiplicity of 1. So my f of x is equal to x times x plus 3 squared times x minus 5. Okay, so if I sketch a graph, and let's see, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, so my degree is 4. My leading coefficient is positive, so my ends are going to go up on both sides. So let's find my zeros and what happens. So I have a 0 at -3. I have a 0 at 0, and I have one at 1, 2, 3, 4, 5. So I know that beyond this, it just continues getting larger and larger. Since these are the only zeros, it never turns around and goes back down. Same thing over here. So now I just have to figure out what happens at each of these. Okay, so at -3, it touches. So it bounces and turns around and goes back up. At 0, it crosses. And at 5, it crosses. So this, and I should put on here, touch, cross, cross. All right, then our very last problem, sketch a graph with a negative leading coefficient and the following zeros. So I have a 0. What is the factor? What is the multiplicity? What is the behavior? So I have a 0 of -4, which tells me the factor is x plus 4, has a multiplicity of 1, so it's going to cross. I have a 0 of -2, so that's a factor of x plus 2, multiplicity of 2, which means it's going to touch. I have a 0 of 3, which means the factor is x minus 3. The multiplicity is 2, so it's going to touch. And 7, which means I have a factor of x minus 7, a multiplicity of 2, which means it touches. Okay. Now, it doesn't tell me to write the function, but I'm going to. So this is f of x, and it doesn't tell me what the leading coefficient is other than it's positive. So I'm just going to call it 1 times x plus 4 times x plus 2 squared times x minus 3 squared. Oh, and I'm so sorry you can't see that. Times x minus 7 squared. Oh, it has a negative leading coefficient, so I'll just have it as -1. I'm sorry, I didn't read that correctly. Okay, so I have a degree, 2, 4, 6, 7. So my degree is odd, and my leading coefficient is negative. What that means is it goes up on the left and down on the right after it does all this stuff in between. So let's see if I can graph this real quickly. All right, so let's see. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so at -4, I have a solution. At -2, I have a solution. At 3, I have a solution. And at 7, I have a solution. I know that to the left of this, it just goes on forever and ever. And here it goes on forever and ever. So I just have to figure out what happens. So at -4, it crosses. Then at -2, it has to turn around and go back up and touch it. Then at 3, it touches. And then at 7, it crosses. Oops, I almost made a goof there. Now, that's one reason I always draw my arrows in advance, because if it doesn't end up going this direction, either I've got my arrows incorrect or something is wrong in my graph. And that is the end of the review. Good luck, everybody.